Good afternoon, all of you. Welcome back to session number second. On the behalf of Yashwantrao Bhosle Polytechnic, I would like to welcome today's resource person, Dr. D R Mahajan, sir. Welcome, sir. In today's session, Mahajan sir discuss about substitution to natural sand by crushed sand in a concrete need of the time. Mahajan sir is working as a head of Civil Engineering Department at Government Polytechnic, Thane. Sir completed PhD at National Institute of Technology, Karnataka. Sir having the experience in teaching professor with over 27 years in the government polytechnic system. Sir having the excellent reputation for resolving the problem and improving student performance and their soft skill. Sir has enthusiastic head of department, eager to contribute to team success through the hard work, attention to detail, and excellent organizational skill, clear understanding of a teaching learning and a training in a soft skill. Sir motivates to learn, grow, and excel in the teaching profession. Now, I would like to request Mahajan sir to start today's session about substitution to natural sand by crushed sand in a concrete need of the time. Sir, mic mute item, sir.
Can you hear me?
Yes, sir. Yes, sir.
My screen is visible to all of you?
Yes, sir.
Okay. So I heartily welcome all to the participants and the organizing team, and I am thankful for them to share my opinions at this platform. So today my topic is substitution to natural sand by crushed sand in concrete need of time. Now this is included in our MSBT syllabus, but just a small paragraph it is there. But in industry, this topic has gone very ahead. So why I developed this interest in this topic is, so one event happened 2 years back when I was working at Government Polytechnic Malwan as HOD and in charge principal. So we have going a big project known as Chippy Airport. It was built by IRB and L&T was this project partner. So the project manager, Mr. Patil, he approached me and he told that we have not getting supply of natural sand and our most of the 60% work is over, and now we are using the buffer stock, and due to environmental ban, collector has not permitted to make or take supply from the river. So what is the alternative? So I suggested him to use fresh sand, and there was only sole supplier in the district. Fortunately, it was there because previously it was not there. So they gave us the mixed design, and for M30 and M35. So we have taken 4 to 5 trials and gave them good mixed design, which wonderfully worked, and they were able to complete their remaining work within stipulated time using the crushed sand. So now there is a need enough hour to use natural sand by crushed sand. So when there is substitution, so it is substitution when the original thing is outdated. But natural sand can be outdated. It is a good choice and it will always remain a good choice. But due to certain concern, we are not getting supply of natural sand or we can't afford it. So by that time, so both are there, both things are there. One thing is, as a civil engineer, we have to complete the project within stipulated time, as that was the case in case of GP or PO. Second thing, if you are using low cost housing, or if you have limited to construction cost, so we have to shift to the alternative which is very good enough to be replaced. So we will have an overlook on this. So concrete is an essential building material which is widely used in construction of infrastructure such as building, bridges, highways, dams, and many other facilities. This current government also have mass infrastructure projects going on all over the country, and it requires a lot of concreting work. So in that concreting work, about 35% of sand is required to make concrete. The main natural and cheapest source of sand is river, which is exhausting very rapidly. So this natural, due to high demand, this is exhausting very rapidly. Also, it is not readily available for all seasons, because in rainy season there is a ban by collector office, so we can't lift the sand due to environmental reasons. So in November, December, they give permission. In January, it starts. Again in June, it is banned. So hardly 6 months is there to take river sand. And also, good river sand is also available at some selected sites. So transportation cost is very large. It may range from 50 kilometer to as good as about 250 kilometers. So the cost of this, it depends. At the diesel rates are increasing, and also due to this frequent traffic, the roads are also getting very distorted due to the heavy traffic of the sand. So there also in Sindhurga district, the road in Kuda stretch was very bad condition due to the frequent movement of this sand dumpers. Okay, so that is not the problem, but the problem is that availability is very less. So there are now, with the increasing, so now for 2 major highways, now all the highways they are using crushed sand. So first initiative was taken in case of Mumbai-Pune Express Highway. There the huge quantity of all the road is concrete, and huge quantity was required for that. So they have taken bold step to use crushed sand, and it works wonderfully. Now existing all this major projects, roads, they are using the crushed sand, including Mumbai-Goa highway also. So other thing is for the collector office, because sand mining they have to put some limit. So when tender opens, they give some this much brass sand you can permit to take. But it is very difficult for them to have close monitoring how much amount of sand they are dredging, because with the good machinery and pumps, large scale sand can be pumped out of the river within less time, and this work happens at the night time. So in the newspaper, you have learned that the sand mafias, they are attacked this Tahsildar and all these Talatis and all these people who are having control over that. So nuisance have increased on this sand mafia. So they discriminately pump this sand from the river bed. Now what happens? This sand acts as a water bank which holds water and it slowly releases in the ground. So the nearby water table is maintained. But if it is indiscriminately mined, then the more sand is taken out. And so the holding capacity of river bed reduces, and this excess water, which was retained previously due to sand, it acts as a runoff and it joins the sea. So the natural holding capacity of this river decreases, and gradually the water table also decreases. So there is harm to the environment also. Due to reduction in supply, natural sand is becoming very costly, thereby increasing the cost of construction. The natural sand is mainly excavated from the river beds and always contains high percentage of inorganic and organic matter, such as silt clay, that adversely affect the strength and durability of the concrete and reinforcing steel, thereby reducing the life of structure. So therefore, we have to switch over to the crushed sand. So there are many advantages. There are few disadvantages too, but that we can manipulate it. So crushed sand is easily available in villages and cities also, because Maharashtra, it is made of 80% of Maharashtra is made of Deccan Plateau, which consists of good igneous rock, that is basalt, and also good rock is more or available in all parts of Indian Peninsula. So there is no problem of availability of good rock in quarries. So from this quarry rock, we can prepare the artificial or crushed sand at any site. So crushed sand has a property similar of that natural sand. So it can be useful for construction. So crushed sand is cheaper than that of natural river sand. The cost is also nearly about half, 50% of the river sand. The concrete with crushed sand performed better than concrete with natural sand, as the property of crushed sand is better than the natural sand. The workability of concrete manufactured with crushed sand was lesser than that of the manufactured with natural sand. Now, this workability, it is comparative term. So, in roads, we required concrete with low workability. In foundation also, we required concrete with lower capacity. So where lower capacity is required, there it is boon, because already it has lower capacity concrete. But if you want to increase the workability for pumpable concrete or highly reinforced structure, then we can easily increase the workability by suitable admixture. So plasticizers, suitable, a lot of plasticizers are available in the market. So easily we can adjust the required slump or compaction factor with the admixture. So, but in case of natural sand, it has ball bearing effect. So it is difficult for it to reduce the workability. It can easily increase the workability, but we can't reduce the workability. So crushed sand has inbuilt property that it has low workability, but it can be increased by using the admixture. So in this way, it is suitable. Compressive strength of concrete is increased when we use crushed sand, because it doesn't contain any impurity. Second thing, the particle size, they are cubical in nature, also they have rough texture. So due to this also, due to rough texture of the particles, the flexural strength and compressive strength are marginally increased than that of the natural sand. Crushed sand is free from chemical impurities such as sulfates and chlorides, which improves the properties of concrete like strength and durability. So crushed sand also contain no organic impurities. So many people dump some body parts and all that remains, those organic waste, and also remains of the pujas in the river because they think that river is a holy. So this organic material pass on and settle on the river bed. So there is chance that these organic particles, which are adulterated by the people due to many reasons, they might mix with the sand and the concrete. So in case of crushed sand, it is not the case because parent rock, they are manufacturing from the parent rock on the site itself, and there is no chance of organic impurity. There is also no wastage in the crushed sand because as per IS 383, we have to use sand below 4.75 mm. But a natural river bed, it is not guaranteed that always that it may have oversized particles. So IS has limited such part due to certain limit. But if it is beyond certain limit, then we have to sieve it. So at the river side, we have seen major sieves. Those who are supplying sand, they have big sieves, and they sieve the sand 4.75 and passing through it only it is supplied. So that remains above the particles, that remains at the river itself. So the cost is increased, but here we have the limit. So in the crusher itself, we adjust the sieves, we get the sand below 4.75 mm. We have 4.75 in Indian, some British or foreign, they are using 4 mm. So as per the required by these countries iron Indian standard or conditions, we can adjust so that we can get the maximum size of fine aggregate. Crushed sand does not harm to any environment in any way, as natural sand provide harm causing bank slides, loss of vegetation of banks, etc. Now let us see or compare the properties of this natural sand and crushed sand. Now first we will see the shape. Now to the attrition, this natural sand, they are all spherical or we will say the ball bearing shape. It is having the ball bearing shape. So as we have seen that it improves the workability. In opposite way, crushed sand has cubical. So cubical is also good. So we can easily substitute here. Now surface texture. So natural sand, it is smooth, and crushed sand, no attrition. Because of no attrition, it is rough. So this has additional advantage that it increases the compressive strength and flexural strength. Then gradation. So we have seen that no control on natural sand because it is naturally happening, and whatever sand we are getting, we have to get the mix design done as per the supply, and we have to use that the natural sand. So crushed sand, it is artificial, so we can have full control on that, whatever zone you want. So nowadays crushed sand can be manufactured for plastering, which is very fine sand, as well as concreting also. So this fineness modulus can be easily adjusted in case of crushed sand. Then particle passing 75 micron. Now this particle passing, it is called as silt. We should be less than 3% as per IS 383 and 2007. Natural sand does have this silt, but if it is limited to 3%, it is permissible. But in case of crushed sand, since these particles contribute to the compressive strength as per many researchers, so as Indian standard has limited, so increase this particles up to 15%. So this dust particles up to 15% it is allowed. So this it is good thing. So the wastage is less. Organic impurities are found in natural sand. They are totally absent. So if organic impurities are found, so we have to wash the natural sand, thereby increasing the cost of the sand. Specific gravity of the natural sand is between 2.3 to 2.7, and in it is little bit higher, 2.5 to 2.9. Now this specific gravity, it depends upon which rock, parent rock you are using. So, but it is not the major cause, because in both cases they are within the permissible limit. Water absorption is also within the permissible limit for both cases, in natural sand as well as crushed sand. So water absorption also not the issue. Now grading zone. So we have repeating this. So sand is by, as per IS 383, it is by classified into zone 1 to zone 4. But for mass concreting, zone 2 is recommended. So we can easily adjust the sieves. So only zone 2 is. So we can manufacture sand from 1 to 4 also. There's no problem. But zone 2 is good for mass concreting, so we can specifically manufacture the sand in zone 2. So workability is good in natural sand. So where the concrete is requiring high workability, it can be easily used with natural sand. But as I repeat again, so where we required less workability, so natural sand is not a good option. There, crushed sand is a good option. So we can usually use concrete with crushed sand. If required, it is improved by admixture. Compressive strength, it is normal. Whatever mix design gives, we can use. We can achieve it by using natural sand. In crushed sand, it is marginally higher. So there is a higher end in case of crushed sand because of this cubical nature and rough texture. So due to rough texture, it has good bond between cement particles and fine aggregate. And also, now the coarse aggregate, it is not naturally available, it is manufactured. So we can say that they are from the both fine aggregate and coarse aggregate. Both are manufactured and from the parent rock. So their combination is more uniform, having physical properties. So this combination is very good because both can be manufactured from the same pressure, same parent rock, but only the size is different. Now leakage permeability, it is less in natural sand and it is very less in crushed sand. So permeable structure, so we can reduce the permeability by using the crushed sand. Now surface cracks. Now natural sand is very showing less cracks, but there is a drawback in crushed sand because tendency to cracks for M15 and M20. It is found that or M15 and M20, which is linear concrete, so they have tendency to show the cracks, but these cracks are not found above M25 and above. So for M25 and above, we can recommend for this. And if you want to use crushed sand for M15 and M20, then to decrease the surface cracks, we can recommend that you have good mixing. We can use suitable admixture, and also little bit cement content will increase, so this crack can be reduced. So we have to take precaution for M15 and M20 concrete. So otherwise, it is no for M25 about absolutely it is very fantastic results. And alkali silica reactivity test both are less than 0.1% as, and it is as per IS limit. So we have just looked this how it is looking. This is a natural sand deposits having different particles, and you can see the cubical nature of the crushed sand. Then literature review. Various studies have been performed on partial replacement as well as full replacement of natural sand by crushed sand. So I also recommend all of your fellow professors, they give this topic and let the students perform themselves in your college laboratory to have these studies, because all these studies whatever in the literature we are getting, they have performed in their own lab. So students should get confidence if they are themselves performing in their own, and also the staff will get confidence. But this topic is limited only to diploma and maximum to degree students. But for master degree and PhD degree, this topic is not recommended, because already lot of research is going on all over the world, and it will be very difficult to publish their results in good journal. So what is the requirement for MTech and PhD? That you have to publish your results in good journal, and since lot of research is already going on and it is published on online platform, so it will be difficult to get this published. And this and until we have really done some wonderful work. So I will not recommend this for MTech and PhD, but diploma and degree level students can work on it, because to popular this crushed sand, and they will have confidence on it, because they are the next engineer civil engineer. Now just we will take a overlook on literature review. So B. Balabkol and Kulkarni 2002, they have investigated the hardened properties of concrete using crushed ballast stone fine aggregate as a substitute to natural sand. So you can see, so 2002 onwards there is research is going on, but now only in few years back it is becoming popular, because construction activity was low and ample natural sand was available. So there is saying that need is mother of invention. So when this natural stock got exhausted, then only people start thinking of crushed sand. Now, similarly, in automobile industry, we were using petrol engine, now diesel engine, then CNG gas came. Now future will be of the electric cars. So why electric cars were no popular? Because now it is a need to use electric cars. So a lot of investment is coming, and companies like Tesla, Tata, they are trying to give best. So similarly, crushed sand is our future. So nearly 80% of work in future, it will be they are using crushed sand. and there is no alternative because we can't afford the natural sand. So natural sand is good. Our first choice should be natural sand only. But if it is costly and second thing it is not available, then you have to switch over to the crushed sand. Sahu et al. 2003 observed that concrete made using crushed sand attained the comparable compression, tensile strength and modulus of rupture as the controlled concrete. Similarly, Vilanovan et al. 2006 studied the strength and behavior of the concrete by using crushed rock dust. Now, see, he has used the material dust as fine aggregate. So they investigated the possibility of using crushed rock as 100% replacement with various compacting factors. So he has studied using the workability study using the compaction factor. Then next researcher Silic and Marar 1996 concluded that partial replacement up to 30% leads to decrease in some value. However, a significant improvement in the compressive, flexural strength and impact resistance was observed. So he had made 30% replacement. A significant reduction in the cost of concrete without affecting the strength property was reported by Logan 2000. Similarly, Saul, Hamid and Shekhar 2009 concluded that compressive strength, tensile strength and durability properties of concrete made of quarry, it is nearly 40% more than the conventional concrete. Now, our real interest, see, now this table I have sourced from this paper. I have Ivanel and Vijay 2013. So they have designed mix from M25 to M60. So as I said previously that concrete below M25 is not performing well using crushed sand. So for pumpable concrete, so they have used this all they are recommended. So maximum size of aggregate 20 mm, and they suggested this mixed proportion. But it is always advisable to use your own mix design and then use in the site. So as per their available resources material, they have this. So for M25 they have used water cement ratio 0.5, M30 also 0.5. Here slightly they have increased the cement content by 20 kg and admixture 600 ml per bag of cement. Now see here this it is very high, this dosage of this. Now because it is pumpable concrete, so we have workability requirement is very high. So for that it is this 600 ml. For normal use 200 to 300 ml is more than sufficient, but since it is a pumpable concrete, so they have recommended dosage of admixture that is 600 ml. Compressive strength, what they have seen that for M25, now if target strength will be higher, it will be 32 for this. So they have achieved this strength 23.8 at 7 days itself, and target strength as per actual strength is near about to target strength. So it is about 30, more than 32, 33. Similarly, M30. So this is the suggested mixed proportion, and it is compressed range well beyond the target. So gradually they have reduced the water cement ratio, and cement content they have increased, and for M60 it is 475. So what mean to say that comfortably we can achieve strength up to M60. So from M25 to M60. So I think it is good representation, mostly for roads and all residential buildings and commercial buildings. We are using up to M35 only. So M40 we are using for girders. So where there is stressing, pre-stressing or post-tensioning is there. So we are using M30 and above. So it is good representation. So we can use this crushed sand with no harm, but with suitable admixtures. Also from the same paper, they have checked for soundness tests also. So soundness test is results are good within the permissible limit for both the river sand and manufactured sand. So that is not the problem. Now about the techniques for manufacturing of the crushed sand. Now previously, crushed sand means it was a byproduct of or waste product. I mean to say it is waste product of the manufacturing of the aggregate, 20 mm aggregate or 10-12 mm aggregate. This what was the byproduct? They used to sieve it, remove the silt, and they were supplying as the crushed sand. But that sand was not good. It was making harsh concrete, and also workability was very low. Now, with latest technology, VSI crusher has come to the picture. So there are many manufacturers of VSI crusher, but about more than 60% are imported. These crushers are imported. Now few Indian companies have now come in the picture. They have started manufacturing the VSI crushers. So just for namesake, I don't recommend, but it is a good company, Pharma Crop, a company named by Svedla. It is one of the concrete manufacturers who have been the forefront for supplying crusher equipments by trade name Jawmaster crusher or Burmac rock or rock VSI crusher, incorporating rock and rock crushing technology. So for this, it is a gimmick, marketing gimmick. Some using the rock and rock crushing technology. So see there, what I say. So as this is a commercial, lots of commercial value. So industry people are far ahead than the academic people. So they do the research, they have a lot of money, they publish in good journals like that. So our academic people, they have a lot of lack resources, money, everything. And so that's why I don't recommend this topic for PhDs or MTech purpose, where publishing in good journal is compulsory. So these companies are very big companies, and constantly they are improving their performance and giving good product. So this rock and rock crushing technology that has revolutionized the art of making concrete aggregates. This imported technology has been used for producing coarse and fine aggregates of desired quality in terms of shape, texture, and grading. So we can see this many manufacturers now. You can recommend your students to have plants in their nearby, because one crushed sand plant can easily be accommodated in a taluk place. So one taluka, the one supplier can handle, but there should not be competition, because that break even doesn't come if there is a competition. So for big cities, as many as mega cities, more suppliers can, more production can be done, but at taluk places only one can be enough. So in heavily density, now when very population is very low, like in Konkan areas, so one plant per district is okay. And this plant, it requires upon 10 crore rupees for having this plant, and it is good business if the people are well educated or they are recommended this to use the crushed sand. But common people are still not so much. It is crushed sand is not popular in common people, so they will prefer to use natural sand only because they are owners, and that for them cost of sand doesn't matter. But in case of big industrial application or government works, definitely this crushed sand can be useful. So if I will start one video. Actually, I have introduced like if you can see this video, it is very nice. It is from YouTube, and same company video it is there. So I will start. Those who have good bandwidth of internet, they can able to see it. But see, just before some difficulty in sharing this, so I will explain this with the cross section. So the cross section of vertical shaft impactor, the VSI crusher, it is known as vertical shaft impactor. It is this is a feeder. This is very compact. This is a feeder, and it's gradually at the main part, it is a rotor. So this gradually, by cascading effect, the flow is of this aggregate is controlled by this cascading effect. So this is adjusted. Now similarly, how the floor mill, that flow is adjusted, and similarly we can get fine floor or coarse floor. So similarly here, this cascading effect, the flow is controlled, that rotor speed is constant, and we can adjust this flow control, and ultimately this aggregate comes here in the rotor itself. And due to centrifugal action, this is very moving with very high speed, and due to centrifugal action, these rock particles are thrown with high speeds on this periphery circumference, and due to this high speed, they collide on each other as well as surface of this rotor, and they break into small pieces. So in this process, these particles are reduced in the sides, and ultimately they fall down. Now this output, they are sieved on the different sieve sizes. So from this different sieve sizes, 600 micron, 300 micron, 150 micron, and what is our requirement, client's requirement? As per the client's requirement, we can supply the manufacturer. There is some waste product also, because in our Indian standard recommends only 15% silt, but here 30% silt is, so 70% only aggregate you get, 30% silt. Of that, the 30% silt, 15% we can use in the safely as the crushed sand, but 30% it can be used for land filling. So there is 15% wastage in this plant. Many crushers, there is some wastage because we have limit in using the silt. So silt can't be avoided. So below 75 micron, it is of no use. As per the IS permits, we can use in the, so our IS permits only 15% silt. So we can, remaining we have to use as a filling the. So these are the references. Two references. There are many such references. So I suggest you to all the staff members to have interest in this topic. Give students this project, let them work, let their self do the mixed design by using both natural sand and fresh sand, and so slowly they will get confidence in, and when they will be engineers, they will have good use of that. So I will share one video.
Sir, video is not visible, sir.
Yes.
Sir,
Hello.
Video
Sir,
is
video is
not
not visible.
Okay, we have some difficulty in sharing the video, but it is easily available on the YouTube. So you can, this Burmac crusher, if you search, it is easily available. I can share this link on the
For just
group.
$67, you can make as many
So
videos as you
they
want.
can share.
Never
See
need
this.
to pick up a camera or use any fancy editing software. With Doodly, you drag, you drop, you tweak some settings, and boom, video done. It'll take you just a few minutes. So let's hear from the Doodly creator, Brad, to see why Doodly is so easy to use and why you should grab this offer right now.
Hi, I'm Brad Callen, and in this video, I'm going to show you how anyone can quickly and easily create doodle videos, just like the one you're watching right now, using Doodly, our drag and drop doodle software that allows anyone, regardless of tech skills, to create highly engaging.
sir.
So any questions are there from the participants?
All the participants should ask the question if any queries to Mahajan sir. All the participants should requested to ask the question.
Okay, then if they can contact me directly in future also. So I am readily available on my number. in the afternoon. So if they have actual, when they are doing this work, if they face some problem, then they can contact me during some they have problem during the MIG design. So not necessary.
Hello.
Ah,
Okay. Thank you, sir. On the behalf of Yashwantrao Bhosle Polytechnic, such excellent session should be conducted by Dr. Mahajan, sir. Which in this session, sir, give the information about substitution to natural sand by crushed sand in a concrete. It is a normally need of a time because of the natural sand should be deteriorative, so that this session should be helpful for the designing of our concrete. Thanks a lot, sir.
okay, thank you.